Welcome to GovCast, connecting with federal IT's top decision makers. I'm Alexander Bolova, production lead at GovCIO Media and Research. With me today is staff writer researcher Anastasia Obis. Hi, Anastasia.
Hey, Alex.
So you had the opportunity to chat with Steven Meier, director of the Naval Center for Space Technology. How'd it go?
It went great. The Naval Research Lab drives so much innovation, not just for the Navy and Marine Corps, but for the Department of Defense at large. So it's always interesting to learn what they're up to.
Yeah, so looking at the name Naval Center for Space Technology, it seems a little bit like an oxymoron. Like, what does water and the vast vacuum of space have to do with each other?
So let me give you a little bit of background on the Naval Research Laboratory. So they're actually celebrating their centennial this year. They opened their doors in 1923, and they've driven a lot of innovation for the entire country. And I'm going to give you a couple of examples. They're responsible for the Global Positioning System, also known as GPS. So that was invented there. It also invented the first US radar that was deployed in the Pacific naval battles of World War II. They also built and launched the first US intelligence satellite in 1960. So these are just a couple of examples. Now, there are 17 research divisions at the Naval Research Lab, and Dr. Meier oversees all of the activities for Naval Center for Space Technology, or NCST. So space is so important to the lab. It has a long history of spacecraft development, and it supports a lot of areas that are important to the Navy.
That is just so impressive to find out that this one lab is responsible for so much technology that today we take for granted. And maybe even crazier to me is the idea that they're celebrating their centennial. Like, this kind of modern innovation has been going on in one way or another for 100 years now, which kind of makes me wonder what new technology they've got hiding away right now that we're going to find out in the next couple of years.
Yeah, there are so many projects. So, for example, the NCST, it supports communications, it supports weather environmental monitoring, intelligence surveillance reconnaissance, missile warning and overhead persistence, kinetic and non-kinetic fires. So there is just so much happening in there. And, during this interview, we dive into some of the projects. So, for example, one of the things that is currently happening there is a project, and it's called Robotic Servicing of Geosynchronous Satellites, or RSGS. It's basically satellite repair robot. We rely on satellites so much, but they're so expensive to build. And once they're launched, they're just out there and there is no way to repair them. So if something were to happen, there is no way to fix them, and it significantly reduces the lifespan of those very expensive satellites. So if this repair robot is successful, and it looks like it will be a complete game changer for robotic operation in space. Another example is we talked a lot about AI and ML, and something interesting that they're looking into is called neuromorphic processors. It's a highly specialized piece of hardware, and it's a lot more energy efficient to run AI and ML systems on than a standard processor. And Dr. Meyer said that these processors are most likely to be the future of AI ML type systems. So these are just an example of a lot of really interesting projects that they're looking into and they're working on.
That is just all so fascinating. And I think it's worth bringing up why this technology is relevant, I guess, in a naval context. I know we've had other people come onto the show and talk about you're in the middle of the ocean. There's only so many ways to communicate and to connect. And stuff like satellites are probably the best option in those really remote locations. And so it's a very practical need driving so much crazy innovation that I really can't wait for our listeners to hear more about. Well, with all of that in mind, let's take a listen to your conversation.
Dr. Meier, thank you so much for joining me today.
Oh, thank you for the opportunity, to share my story, and I really look forward to the discussion today.
Yeah, of course. And could you introduce yourself and tell us about your career trajectory and what your current role is?
Sure. Be happy to do that. Let's just kind of start from the top. I currently serve as the director of the Naval Center for Space Technology at the Naval Research Lab. So in this role, I'm leading up all the organization's space technology programs, really in support of the Navy, the DoD, the intelligence community, civil, commercial, and international space communities. So it's quite a large portfolio. So everything I oversee, ranging from basic research to advanced development of spacecraft systems and technologies, as well as several ground command and control stations. So really, what our core function in NCST is, we take ideas from paper napkin all the way to operations. Everything that includes design, build, test, and operate of space systems and technologies, all within one organization. So that's my current role. So when I thought about your question, I look back a little bit. As I reflect back on my career, there's several experiences that prepared me for such an exciting position that I'm in right now. Because space currently is at a huge inflection point, probably the largest inflection point in decades. So really, it started, my early career was as a scientist in the lab, building hardware, software, publishing papers, and presenting at technical conferences. So really, those experiences provided me a very deep understanding and strong technical underpinnings of many fields such as spacecraft systems, astrophysics, material science, applied optics, and other technical disciplines. So this deep technical understanding really allowed me to listen today and work directly with scientists and engineers in my organization, because I have that ground level experience and can speak the language, understand their issues, understand their trades. So after obtaining my PhD and having spent many years in the lab, getting that strong technical base, I decided to transition to leadership roles that started as a project manager, program manager, director, vice president industry, and SES positions at both NASA and the Naval Research Lab. So all these roles require greater responsibilities that involve really leading people and organizations. And to prepare for those positions, I took several executive leadership classes. I read several books from leaders, and I also took many classes along the lines of project management, finance, accounting, federal contracting, and systems engineering. But just as important as those classes was that I found it, I was very fortunate to have both technical and leadership mentors during my career. Mentors can make a huge difference in your career. And based on my own experiences, I believe in paying it forward, and currently have several mentees in my current role. And, I just think back of one mentor I had at the National Reconnaissance Office. He really is a leadership mentor and really taught me how to think really from top to bottom instead of the bottoms up approach, where a lot of people, get mired back in the details. Really like reading a schedule or thinking of a technology roadmap, thinking right to left. And that was really about visualizing the end state of a certain technology system. What does it look like in its final state? And then working really from the right-hand side and then developing all the technologies that were needed to meet that and going to the left. Many people will, start from the left-hand side and think, what hardware, what software, what systems do we need, and go left to right. He really taught me to go right to left. So it was, big picture visualization. So that was really key in my development as a leader. So having those mentors. And then also my private career, my total career really is, span both the public sectors at NRL, NGA, NRO, and NASA, as well as in the private sector at Lockheed Martin, Raytheon, and Perspecta. So having worked on both sides of the aerospace industry, it's really enabled me to understand the drivers and perspectives of both government and industry who need to work together. I mean, the US government and US space industrial base will always be coupled together. So my experience has helped me create that useful balance of knowledge across both sectors. And then lastly, my entire career as I look back has been working in research and development and science and technology organizations. It's really been focusing on building innovative, high risk, one of a kind, ground, air, and space technologies and transitioning to other government agencies, private industry, and the commercial sector. And all that really fits in perfectly with my current role because that is exactly what we do here in NCST.
Yeah, absolutely. And before we dive into the Naval Center for Space and Technology, could you tell us what does the NRL do? Obviously, there's so much happening. There are so many projects and activities, but I wonder if you could give us an idea of what some of those programs are.
Sure. I guess I'll give you the big picture. I mean, NRL is the Navy's corporate laboratory for providing advanced scientific capabilities required to bolster our country's position of global naval leadership. So, and in fact, just this year, we're celebrating our centennial. So we've eclipsed 100 years of existence. So it's really exciting. We opened our gates in 1923, and really, since then, NRL has galvanized the way our military wages wars and has given the U.S. an advantage in the fight. We've advanced capabilities, prevented technological surprise, and transferred vital new innovations to industry. And just a couple examples going back, of our past rich history in this area is NRL, invented the first U.S. radar that was deployed in the Pacific naval battles of World War II. So that really helped, win the Second World War. We also designed, built, and launched the first U.S. intelligence satellite in 1960. Technology that kept the Cold War cold. And we've invented, concepts, prototypes, and operational satellites for systems that exist today, such as the Global Positioning System, GPS, where we all rely on that for locations and, position where we are and how to get from one place to another, in addition to the economy, financial industry, and other places that, GPS affects. So we've had a really exceptional record of making vital, sustained contributions to sailors and Marines and the U.S. economy. But the big picture, we consist of 17 research divisions that span projects from splitting the atom to launching spacecraft into orbits 22,000 miles away. So we lead, advances for the Navy in space systems and development, tactical electronic warfare, microelectronics devices, hypersonics, quantum information science, and artificial intelligence. So it spans a wide breadth, as you can tell, of science and technology that is supporting the Navy, the DoD, intelligence community across the board. And another important element to what we do at NRL is information sharing. Our researchers routinely present and attend international conferences in their areas of experience, broadening the scope of cooperation with U.S. allies and partners.
Yeah, and before we dive into the specific projects of the Naval Center for Space and Technology, I wonder what role does the NRL play in the ecosystem? So specifically how it fits into the Navy's mission and also within the DoD's goals as they're laid out in the National Defense Strategy.
Sure, we directly support the Navy in all of those areas that I mentioned previously. So again, as the Navy's corporate laboratory. What we do, with respect to the Joint Force and the National Defense Strategy, we create advanced technologies that provide the Joint Force modernized systems needed for that advantage. So we're working on critical technology areas that are called out in the National Defense Strategy, such as hypersonics, artificial intelligence, integrated network systems of systems, again, microelectronics, space, human-machine interfaces, all of those different areas. So as laid out in the NDS, we know that leveraging commercial space capabilities, linking them with our joint warfighter is necessary to really maintain that operational advantage over competitors. So at NRL, in many cases, we act as a channel between small to medium defense technology companies, government agencies, really enhancing collaboration and ideation. So, and another important element to what we do at NRL is information sharing. Our researchers, are routinely present and attend international conferences, based on their experience, broadening the scope of U.S. allies, cooperation with U.S. allies and partners. So we cover and support all those areas in support of the joint forces and the national defense strategy.
Yeah, and also, why is space so important to the Navy? Why is it so interested in space?
Yeah, the Navy, has been delivering, space systems in support of the national defense community for a long time, going back to the 1960s. So, what's important to the Navy is, really when we're in operations, we are the only force that's constantly moving. We're constantly on the go, ships, submarines, airplanes, all of the above. So we support 7 key areas that are paramount importance to the Navy. Number one, of course, is communications. You can't drag a fiber optic, across the ocean and stay connected. So space-based communications assure high-quality command and control of our forces anywhere on the planet. So it's a vital element of our work to ensure naval systems work well with each other in collaboration with other DoD and intelligence community space systems. Communications, I'd say, is number one. Number two is weather and environmental monitoring. We don't have Doppler radar systems in the middle of the ocean. So really predicting, weather conditions and, that are global, and in addition to solar weather conditions as well, because solar weather may hit, there's solar flares, coronal mass ejection, and can directly affect Navy and DoD communications. So the next would be position, navigation, and timing, important for really sailors, Marines to know where they are and where they're headed globally. Would be number 3, intelligence, surveillance, reconnaissance, also known as ISR, provides information to maritime domain awareness, where we track everything from canoes to freighters, globally, that can impact, the safety, security, economy, environment of the United States. So number 4, I would say, is number 5, missile warning and overhead persistence. Space again provides, launching missiles and tracking ship to ship, land to ship, and ship to land. Vital information for the Navy to know. And then 2 areas that we're concentrating now that are more relatively new is kinetic and non-kinetic fires. These are space assets utilized to detect and prevent long-range missiles from our adversaries, through kinetic, which is, more physical assets, and then also non-kinetic, which is implementing electromagnetic pulses or cyber techniques to prevent this threat. And then lastly is C5 ISRT, that's really providing global situational awareness of the oceans and battlefields. So we support all 7 of these areas, from basic research to operations and NCST. We have the capability to build, CubeSats the size of a thermos to large satellite systems up to 15,000 pounds. And then also we support the Navy and DoD with 3 ground stations within NCST that can actually carry out the Navy's DoD and IC space missions. And within NCST, again, we have that full end-to-end testing capability where we can take it from the paper napkin, build, design, assembly, integrate, test. And what's really important is the testing of shock, vibe, thermal vacuum systems, electromagnetic interference, and then we can essentially run it through our entire system, place it on a truck that ships it out to a launch site. And just to reiterate again, it's these first of a kind, high risk, innovative technologies, that supports the Navy's unique maritime operations missions.
Yeah, of course. And we'll talk more about the process of building and then fielding it before we do. So one of the programs you've been working on for a long time is robotic servicing of geosynchronous satellites. So it's a really fascinating project. It's based on decades of research. Could you talk a little about what the program is about and what it's trying to solve? And especially if successful, what it would mean for the satellite industry?
Sure. I'd love to share some information on that, because that has been, we've been working on RSGS for quite some time. But let me start from the top of like the application. I mean, in military fields, there's a lot of expensive platforms, as you know. And so there's ships, submarines, fighters, bombers, aircraft tanks, and so on. So for every one of these systems, we can fix them when they break. So we can upgrade them when new technology becomes available. With the Navy ship, for instance, the hull is expected to last several decades. So we periodically bring ships in back to port, retrofit them with new computers, radars, weapon systems, and so on. Then they go back to sea. It's like having a new ship, except we didn't have to pay for the entire price of building a new ship. Now, similarly, another good example is the B-52 bomber. The last B-52 airframe came out of the factory back in 1968, a long time ago. But we keep maintaining and upgrading B-52s, and it's entirely possible that some of the airframes will be in service for over a century. Modern B-52s have been upgraded multiple times, so now they have GPS navigation, glass cockpits, and so on, and they use weapon systems that weren't even conceived in 1968. So now we go on to spacecraft. So we can't do that today with spacecraft, and it takes and costs a lot, to develop and put a new spacecraft with new technology into space, into an orbit. So if there's a new instrument we want to fly, we have to design, build, test, and completely develop a new spacecraft and satellite to host it. So really, our history in this goes back approximately, like, I'd say 2 decades. We started working on that, and it came out of an idea in NCST. Somebody said, hey, why don't we invest in space robotics, which I'll talk about later, goes to our bottoms-up innovation. Back then, people were like, what are you thinking about with space robotics? Why should we invest in this? And look where we are today with RSGS. So for the past 2 decades, NRL has been working really in the space robotics regime, and RSGS, is really developing an unmanned space robotic, satellite servicing. We've taken from concept to a fielded national capability. So that's really what it is in a nutshell. So we work with DARPA. They're our sponsor. So we are developing the payload, which consists principally of 2 robotic arms about 6 feet in length. And Northrop Grumman and their subsidiary Space Logistics is building the satellite bus. And a satellite bus essentially supports the payload by providing structure, power, commanding, telemetry, appropriate thermal environment, radiation sealing, and attitude control. So once on orbit, RSGS, will essentially inspect and service satellites in the geosynchronous Earth orbit, GEO, which is out to about 22,000 miles away or 36,000 kilometers, where there's hundreds of satellites that provide communications, weather monitoring, support national security missions, and other vital functions that go on for the U.S. So RSGS is designed to be the robotic mechanic for these satellites. We're able to go out and extend the life of existing satellites. In some cases, repair broken satellites, upgrade satellites currently out in GEO. So it'll be the first operational spacecraft capable of grappling, repairing, and upgrading satellites. So we're able to move assets around, inspect assets, understand root cause of failures, free, suck, and deployable assets that may be up there, and attach, leave behind payloads. So what's even more unique about RSGS is it's going out to service satellites that are not meant to be serviced. So that's what's even more unique. So it's going out there and working on that. So that's like RSGS, in a larger, more, bigger picture on where it's going. So to your last question, so what if RSGS is successful? Ultimately, I believe RSGS will be successful. And what it will do is serve a key element, as being a key segment of the space logistics chain. So logistics, if we start out, is really the physical flow of moving people, resources, goods, materials, services, inventory from one destination to another. So RSGS will be a key link in this logistics train by delivering these items to a spacecraft or perhaps even to a lunar surface. So that's really what it's successful like. But also, however, for this to happen, there's a couple things that we would like to, once it's successful, influence the DoD. One, we just start requiring modularity in new satellite designs. That's really putting together fast development, low cost, general purpose spacecraft systems. Modular designs intended to reduce cost, complexity, and lead time on missions by providing reliable, well-characterized systems that can carry a variety of payloads. And you'll be able to, they're more related to size and weight, and you'll be able to, if they're modular, take one system out and put a new system in, very simply. And then the other part is commonality, where they're electrical, mechanical, optical interfaces that are all common. That's essentially like a plug that's going to go into your wall socket, or a USB that connects into your computer. That's commonality. Having interfaces that are common, where again, you can just essentially like plug and play, to go in there. And then the last one would be having a launch infrastructure that's rapid and responsive. That we have, launch vehicles, rockets on the side that can, launch, systems into space, whether fuel or solar array or batteries or whatever it may be. So having that launch infrastructure that's rapid and responsive. So, our vision RSGS would go out then to like a fueling depot, supply depot, and move equipment into just like logistics and repair to other areas to take care of these satellites and do everything that it does. So if these conditions really come to fruition, the true impact is that RSGS can be a pathfinder to a new generation of satellites that were built to be upgraded the way a ship, aircraft, or tank is. So we're really excited of the impact down the road about the future of space robotics and what it will do for space logistics.
Yeah, and another piece of it is that AI and machine learning are a key part of a spacecraft. What kinds of challenges is your team working on overcoming when it comes to facilitating technologies like AI and ML in robotics field, especially as it relates to this project or other projects that you're working on?
Sure. AI and ML is pervasive across the community, as you know, in several different fields, space being one of them. I mean, one thing I would like to do is just, spend 30 seconds on describing AL versus, ML. AI is really a general term for making robots and other systems, making them be able to make intelligent decisions with the goal of making them as intelligent as a human operator. So ML is a subset of AI where a robot learns on its own how to make intelligent decisions by exploring the possible decisions it could make and trying out some of them and remembering the results. ML is really when a robot teaches itself to do a job. So if you wanted your self-driving car to recognize stop signs, you would give it a bunch of pictures of road scenes with labels, that told it which ones the stop signs, which ones didn't. And then it learned on its own to tell the difference. That's machine learning. So, about a decade ago, AI and ML came onto the scene in the satellite community. Most applications were really focused on analyzing satellite big data that comes down, the satellite images and communications and signals and other things along those lines, because there's large volumes of that. So in the satellite community right now, we're interested in using AI to control robots and other autonomous systems. This is a challenge, though, because AI and ML types of systems tend to be very brittle. They break, often catastrophically. So when it encounter situations it wasn't designed for to be trained on. So we're using cutting-edge ML techniques and making use of new software and hardware infrastructure that will let us retrain ML systems very, very quickly, possibly as quickly as a few minutes. We want to give the ability to retrain systems to solve new problems to our warfighters who are actually using these systems. So as AI and ML is used today, we have to download all the data, analyze it on the ground using substantial computing resources. So what we're looking at, again, going back to that satellite big data. And it isn't really feasible to fly computers that big on most spacecraft. AI ML systems take up too much space, require too much power, and generate far too much heat. So we're looking at ML algorithms that can process data using smaller computers, and we're working on designing computers that are as powerful as the ones used on the ground today, but only require a fraction of the power, and it's much easier to dissipate heat on these systems. So someday soon, we hope to fly computers and AI ML algorithms that can recognize objects or phenomenon of interest on board and just download the pertinent data directly to scientists or warfighters. So in terms of really what we're pushing forward at the state of the art in NCST to help facilitate this for satellite systems or others, are some developing novel types of computers that work more like a brain than a regular computer like your laptop. So a regular computer, for the most part, does one thing at a time, quickly. But the brain is actually pretty slow. A single neuron, in your brain is about 10 to 100 times slower than a simulated neuron in an artificial neural network. Yet brains, on their own as a whole, are quite fast. That's because your neurons operate in parallel, mostly independent of each other. As a result, the brain can make decisions very quickly, and it turns out, that calculating this way is much more energy efficient. So one type of novel computer that we're investigating, it's called neuromorphic processors, that you put on a computer. These type of processors, implement artificial neurons in this way that turn out to be 100 times more energy efficient than the same ML system being run on a processor, your standard processor. So we have, several of these processors that are very unique, and we feel are like the future of AI ML type systems. So RSGS uses just enough AI to do its job, because RSGS, isn't necessarily by trade experiment to demonstrate AI and ML in space. It's an operational spacecraft that's expected to really reliably service very expensive satellites, at least for a decade. It uses carefully designed state machines that understand sequences of tasks to carry out and can determine whether or not they've been carried out as expected and what to do if something unexpected happens. So we've tested these systems in our labs for over a decade, and we're very confident will work as designed. But to some degree, they're limited in some cases as well. And you do need some humans on the ground to figure out what happened, with the RSGS system. So, our goal is really, we want to fly these spacecraft that are totally autonomous. They'll only need, to phone home every once in a while to tell the satellite scientists and engineers, it's a job done and needs new assignment. So this will require new AI and ML techniques and better flight computers at the end of the day. So, and then another example of an AI ML application is an NCST program called AutoSat. It's very exciting. So it's currently a satellite lab demonstration that infinitely calibrates itself and operates autonomy. It involves AI, ML, and supervised learning and convolutional neural networks to achieve its goals. So in essence, the way it operates is it has a database that's been loaded onto it with Earth landmarks such as airport runways, city buildings, streets, and others, so it can understand where it is. So it moves around, it actually learns how to navigate autonomously, uploads more pictures, takes pictures, uploads them with a sensor which has about 1 meter resolution. So it just moves around, increases the size of the database, understands where it is, and it's just a direct download when it gets images down to a ground station. There's no uplink from a ground station. It learns as it goes. It collects more data. The AI builds a database and allows it to continue to get smarter and smarter wherever it moves around globally. So, and there's absolutely no human in the loop. But what the real impact of this is that it's an ability to operate a satellite system in a communication or GPS denied environment if GPS were to go down. So if 2 or 3 GPS satellites goes down, we've lost communication navigation. This type of constellation we view, we're building we have the precursor of a lab demo. You can put this into a constellation where if the constellation uses it, loses the GPS environment, we'll be able to continue to navigate and send images down to the Earth. So that also is a very exciting, area that we're working on in AI and ML and convolutional neural networks to push the state of the art.
Yeah, and since we're talking about other areas, what are some of the projects that you're currently working on?
Sure, we have a couple ones that we're very excited about. Number one, I'd say, is our, the SDA. We are the prime contractor for them doing the entire ground segment. They just launched their second tranche of satellites. The total SDA Tranche 0 consists of 28 satellites, and out of NCST's Blossom Point tracking facility. It's very exciting. We are in charge of the entire constellation. We're doing all the mission management, systems engineering, and orbital analysis. So just recently on Saturday, SDA launched, as I mentioned, just recently the second tranche, and we're currently now working on the command and control. So it's a very exciting program, changing the face and paradigm of space constellations with a resilient network of integrated capabilities. And it's a tough problem to solve. I mean, we're working with 4 separate contractors, SpaceX, Lockheed Martin, L3 Harris, and New York Space Systems. And we've essentially developed 4 custom solutions, and it's our job to weave all of those custom solutions into an integrated network. So it's a challenge, but that's why they chose us, because we have an exceptional team down there. And in terms of what we're doing there with respect to AI or advanced technologies, we're continuing to investigate command and control, mission management software, using AI for fault detection, prevention, mitigation of ground and space assets, and to drive decision-making really from the ground into the space layer, to decrease latency. So that's one area with the 3 ground stations. We're very excited about working on these areas and also using AI and ML types of algorithms. We're also focused on hypersonics. That's a big area for the Navy. We've, within NRL, we've invested, in a new hypersonics wind tunnel that's expected to be completed in the January 2024 timeframe. It's going to have very unique capabilities with it. And then in addition with that, we won the DoD Applied Research for Advancement of S&T Priorities, called an ARAP, Program Award Competition. We won with our program called Surface Morphing and Adaptive Structures for Hypersonics, called SMASH. So it's very exciting. We came out #1 of 17 proposals with the team here. So, and we're leading up a DoD research team with the Air Force Research Lab, Army Research Lab, Missile Defense Agency, as well as 20 academic partners. So it's very exciting. So we are becoming, in my view, a hypersonic center of excellence. And this will really improve and advance hypersonic systems performance, lethality, durability, flexible surfaces, lift, maneuverability, efficiencies. So it's a very exciting area that is of paramount importance to the Navy, and we're becoming on the cutting edge of that. And then another area is power beaming and space solar. We again have, on the forefront of this. I would say power beaming and space solar are the equivalent to what robotics was about 20 years ago. And space solar is collecting solar energy in space and delivering it via power beaming for use on the Earth. So without power beaming, there's no space solar. So it really comes to collecting sunlight in space and sending it wirelessly to the ground. So it's a very much, power beaming is an emerging technology that could revolutionize how we deliver energy for defense, civil, commercial purposes on Earth, in space, or on the moon. So at NRL, we developed the first demo of this. We flew aboard the X-37B, where we converted sunlight into microwave energy. It's called PRAM-FX, the Photovoltaic RF Antenna Module Flight Experiment. And it really was the first orbital demonstration of space solar. It was launched in May 2020 on the X-37B orbital test vehicle, and the mission concluded successfully in November of 2022. So that's really exciting. And the second one, Swell, just went up in March of 2023. It's the Space Wireless Energy Laser Link. And it was the first demonstration of laser power beaming in space. It's actually currently aboard the International Space Station, and it was hosted on there and is planned to operate for about a year. Again, demonstrated the first laser power beaming in space. So it's very exciting. But the true impact of space solar and power beaming is twofold. I mean, it would produce capability to deliver power globally anywhere in underserved areas. Such as forward operating bases, other around globally. You don't have to move fuel in risky areas. You don't have to put out use batteries for everything, or run fuel lines or trucks or whatever it may go. So it's able to deliver globally. And in addition, space solar is a green energy because the sun's going to be around a few billion more years. So it kind of has those two big advantages of power beaming and space solar. So it's an exciting thing that we are, again, at the demo stage and are continuing to build and advance the technology there. So those are a couple of the areas, that we're working on with ground stations and systems and advancing state of the art, also with hypersonics, and then space solar and power beaming.
Yeah, and also, how do you make sure that the projects don't get stuck, that you bridge that valley of death and the technology actually makes it out to the field?
Sure. There's a couple ways throughout my career that, it is a common failure point is hitting the valley of death. You build the technology and then you don't have a transition partner and it kind of dies and doesn't get transmitted to operations. So really the impact of technology dying in the valley of death is that it prevents the national security community from adopting innovative, cutting-edge technologies that can provide, new defense applications and intelligence. So that is really the impact. So my own view, I've implemented several practices throughout my career to surmount the valley of death. One first is like involving the end users and operators early in the technology development phase to understand what the final product size, weight, and power looks like, what the features are, what the functionality is required. So this is a best practice I've learned. And early in my career, I actually, I was part of an organization that we built an aircraft payload. It's very unique. Cost a couple $1 million. We flew it overseas, connected new intelligence products. We brought it back, and it turned out that I didn't involve with end users and operators, and we didn't end up transitioning the technology. The issue there was, I went to several transition partners after the fact, and I asked them, can we fit this into your aircraft? And like, no, it's not the right size. We only take a certain amount of weight. Your thing is too heavy. How long do you loiter? I'd say for 2 to 3 hours, their battery works. They would say, well, we need it for 7 to 8 hours. So I went to several transition partners and never transitioned it. So that was a hard lesson learned from it. But at the end of the day, it did prove a new, source of intelligence, innovative technology. So it was exciting in that regard, but unfortunately we couldn't transition it. Another success story down another area that I'd say is develop a system requirements. It's all about requirements up front. That includes, again, inputs from the users, the operators, and the mission partners. That is really key. And then keep those requirements stable and unchanged. For example, we worked on a high bandwidth optical communication system for the Marines called Talon. And we were very successful in that and transitioned it over to the Marines to be their first major defense acquisition program, also known as NDAP, of high bandwidth, optical communications. And how we did that is essentially my scientific principal investigators, the lead, sat across the table with the Marine commander, and they built the requirement set, and she got direct input from the user and the system is going to be operated in. We tested it all around the world globally, everywhere from very cold places to extremely hot places, and they kept the requirements stable, and then it seamlessly transitioned over to the Marines. So that was a great example of sitting across the table, getting those requirements nailed down, and keeping them stable and unchanged. So that was a big success story. Other areas I found in my career from working in R&D, S&T organizations is develop risk assessments early, develop end-to-end test plans. So it kind of goes back, how are we going to test this? What are the risks that we're looking at? Develop a concept of operations. I kind of mentioned that already on my own aircraft program. So you understand how the technology will be operated in its intended environment. That's very key. What are the concept of operation or ConOps? And then also one thing that's almost political but helps out is develop a stakeholder communication plan and keep stakeholders up to date so they continue to advocate for your technology program. Unfortunately, if people don't hear about what you're doing, your mission partners, your stakeholders, unfortunately, they might view that in a negative light. But if you keep people up to date via meetings, emails, phone calls, they will continue to advocate for your program. And then lastly, one I would say is really having continuity of personnel for the entire project. Because again, the project is not just you, it's having the scientists, the program managers involved so they can maintain the knowledge as you continue to transition the technology and build it and transition it. So as you know, anyone entering a new program, there is a learning curve. So they maintain the knowledge and also the relationships with the mission partners, operators, and users. It's really key to maintain those relationships. So you need to stay, joined at the hip throughout that. So continuity is really key of personnel, so they can go through. So that's, those are some of the practical lessons I've learned and adopted, I've had successful transitions, to surmount and, overcome the valley of death.
Yeah, and when it comes to partnerships, what are the agencies do you partner with? So what about industry partners? What about academia? Who do you work with?
Well, we have a business model called a working capital fund. And essentially all of our funding, 99.9% or thereabouts, comes from external sponsors. So this business model drives us to work very closely with the Navy, the DoD, the IC, and civil space communities. So we have to bring funding into our organization. We essentially write proposals, we write white papers, we go out and do business development as best we can to bring money in, because that is the way our organization works. So it drives us to work with a variety of sponsors. So within NCST, we work with the commercial space industry. Already mentioned working with DARPA on RSGS. Also with the SDA work, we're working very closely again with the Space Development Agency, SpaceX, Lockheed Martin, L3 Harris, New York Space Systems to implement this new space architecture. So we work across a wide breadth of government and commercial partners. So because we're really coupled together. And we also collaborate with academia a bit through educational partnership agreements. For example, NRL just recently transferred some equipment over to the University of Notre Dame, where we use to train the next generation of scientists. Within NCST, we have 6 academic partnerships that cover hypersonic materials, propulsions, and aerodynamics. And there'll be more of those, as I mentioned, within our SMASH program working with even more university partners. And then also we're part of the National Science Foundation Center for Space, High Performance, and Resilience Computing for several years. The SHREC affords us an opportunity to vote on space research thrusts at places such as like the University of Pittsburgh, Brigham Young University of Florida, and Virginia Tech. So we can align research and interest towards NRL. And also it serves as a recruiting pipeline as well. As will the Hypersonics, working with a variety of universities and some of these others. So we have very rich, fruitful collaborations with other government industries, private industry, and academia to really rapidly conceive and demonstrate revolutionary space technologies for the Navy, Department of Defense, national space community.
Yeah, and also when it comes to talent, do you experience any challenges there? And what would your message be in terms of why the talent should join the NRL instead of other labs?
Sure, thanks for the opportunity to address that. Hiring talent in the technology world, and particularly in space right now, can be a challenge because there is so much investment in space in other government agencies and in private industry. But we in NCST bring distinct opportunities that are not found anywhere else. I mean, for example, I worked, at the NRL and from 1998 to like mid-2002 as a research physicist building hardware and software. I had the opportunity to work on many projects, at once with several sponsors working across the lab with other divisions. So, my message here is if someone were to come here, you'll have an amazing experience early in your career to get the broad brush. And that is driven a lot by our bottoms-up innovation model. We're working with several external sponsors, and we drive that type of, entrepreneurial approach with going, forward and hiring talent. I mean, really, we're unique, and incoming junior and mid-level engineers and scientists come in. They really have an opportunity to immediately, as we say, turn the wrenches and bend metal to get really great work experience early on in their careers. You won't find that potentially, private industry or other national labs. So we also employ some of the nation's best scientists and engineers. I mean, at times I'll look up who is an expert, and I might be able to just walk over to another building and find someone who is the international expert. So the scientists and engineers really have the opportunity to work with renowned national and international experts in the respective scientific fields. So, and then the other aspect is, joining NRL and NCST, we truly have a compelling mission, that inspires scientists and engineers to pursue their passion and support the national security and defense of the United States. We really do all of our work with a purpose in mind, and we're looking for service-minded individuals, that want to make an impact on U.S. national security. And again, just to reiterate, that working capital funded model really allows any scientist or engineer to be an entrepreneur. Most other service labs are funded with congressional appropriations to do funded projects. We are not. So it does drive that entrepreneurial spirit. So writing white papers, responding to proposals, NCS team and NRL employees can have an idea that can be realized. Come up with an idea, you go out and work with a sponsor and you get it funded. And it really kind of goes back, that bottoms up innovation environment where ideas come directly from the workforce, all the way from concept to operations. So that's what makes NRL and NCST a very unique place to work.
Amazing. Dr. Meier, thank you so much for joining us.
Oh, you're welcome.
Yeah, and it's just amazing to think that all this activity is happening just outside of DC.
Yes, I know. We're only about 15 minutes from downtown DC. Yeah. So we're always open. If someone wants to come out and visit, we're always happy to give tours and talk about what we do, because it is a very exciting place to do, where people get, we do incredible things here for, the entire national security community. And, really, it's a great place to work at NRL and NCST.
Absolutely. Well, thank you so much.
You're welcome.
Thank you, Anastasia. That was really, really fascinating. I mean, space, technology, robot, satellite, whatnot. I'm constantly having to remind myself that we are really living in the future. Before we wrap up the podcast, are there any last highlights or takeaways that you want to leave our listeners with?
Not really, just enjoy the episode. It's so interesting what they're doing in that lab.
Well, hopefully we'll be able to get Steven Meier back on the podcast in the next couple of years. I imagine that there is even more innovation to talk about then. But in the meantime, if you want to keep up with everything happening in the federal IT space, make sure that you are subscribed to GovCast, as well as our sister podcasts, Cybercast and Healthcast. We'll be back next week with a brand new interview. But in the meantime, leave a 5-star rating and a review on the podcast platform of your choice. I'm Alexander Bolova.
I'm Anastasia Opus.
Thank you for listening. GovCast, along with Healthcast and Cybercast, is a production of GovCIO Media and Research. For more podcasts and to check out the other shows, head to govciomedia.com. Watch out for new episodes released every Tuesday and Wednesday across our shows. You can follow all of them on your favorite podcast platform. And if you like what you heard, make sure to let us know by leaving a review. And if you have any topics you think we should look into, contact us at newsletter@govcio.com.